Okay friends, we'll continue here to find out pi by using shortcut method. Next is we have to find out pi for this function f of d into, and I am taking here right hand side as polynomial x raised to power m. If right hand side is a polynomial, then we have to find out pi. Now here in this case formula you can write here this as f of d, and we are taking inverse of this into this polynomial x raised to power m. But when we are solving problems under this, we have to note this. Under this section we are solving this problem, we need this formula 1 divided by 1 minus z is equal to 1 plus z plus z square plus z cube plus so on. This is series expansion of this function 1 upon 1 minus z and 1 upon 1 plus z. Similar way we can write here 1 minus z plus z square minus z cube, alternate plus or minus so on. Again here this condition satisfying, this mod z is less than 1. We are using this formula because we are taking here inverse of this, and this is 1 divided by 1 minus z. This is nothing but inverse of 1 minus z, and from that this is binomial expansion, and we will get here pi by using this method. Again important thing, condition is here that sometimes what happen here in f of d, we have to take inverse of this f of d. When we are taking inverse of f of d, we are taking here in f of d is in denominator, that means in denominator, or I will write here from f of d which is in denominator, here we are taking smallest degree term as common. Means here while solving problems under this is also important. We are taking here in f of d, if it is in f of d we are taking smaller degree term as common, and then we are finding inverse of this. Okay, we will get this idea again here clear why we have to take in this way. If we are not taking in this way, then there will be problem to solve this type of problem. We are not getting finite answer for particular integral. Okay, we'll solve some problems on this, and then also we'll get this idea clear. I will take example here. We have to find pi. Suppose I will write here d square minus 1 of x square. Means our right hand side is a polynomial function, and we have to find pi for this function. Now here I will take minus common, and I will write here this is 1 minus d square into x square. Now we have this result 1 upon 1 minus d square. I will apply this result here, and using this result I will expand this term minus this is 1 divided by, I will suppose this as z. This is 1 divided by 1 minus z, means here we will write here 1 plus z is here d square plus d square raised to 2, and so on terms are there. But again here this is x square, and we are knowing that whose second derivative becomes constant and third derivative becomes 0, and here this is d square raised to 2, that means total d raised to power 4th. Surely its fourth derivative becomes 0, and remaining terms of higher derivative of this. Therefore I will stop here. I am not taking higher terms into x square. This is equal to minus 1 into this x square plus d square operating on x square, that means we have to take double derivative of this x square. That means we are getting this is first derivative is 2x, and then derivative is 2 plus, and its fourth derivative is 0. Therefore we are getting this is equal to minus x square minus 2. This is our pi. Again I will take another example. Example number 2. If suppose my function is, suppose our differential equation is d square minus 3d into y equal to x square plus 3. We'll take x square plus 3x plus 2. This is our function and we have to find pi for this. Now we can apply shortcut method and I will consider this total function as a polynomial function, and I will write here formula for pi is equal to 1 upon d square minus 3d into x square plus 3x plus 2. Now you can check here, if we can take here d square as common as well as 3d also common. I am taking from denominator d square outside or 3d outside. If you are taking d square outside, then you can check here what will happen when you are finding this pi. But again condition is that we have to take smallest degree term, lowest degree term as common, and lowest degree term is 3d. I will take 3d common. 1 divided by 3d, moreover I will take minus 3d and bracket. Remaining term is d square divided by minus 3d minus minus plus 1 into x square plus 3x plus 2, which is equal to 1 divided by minus 3d into bracket, I will write here 1 minus d divided by 3 into x square plus 3x plus 2. This is nothing but minus 1 divided by 3d into, I will write here expansion of this term. I will suppose this is just like 1 divided by 1 minus z. Z is our this total term. 1 divided by 1 minus z. Z is our here d by 3. And here is 1 plus d divided by 3 plus d divided by 3 whole square plus, I will write here another term, d divided by 3 whole cube. Here d cube, and we are knowing this is second order again. Third derivative becomes 0. Therefore, I am not taking higher terms. Into x square plus 3x plus 2. Now, this is minus 1 over 3d. In this bracket, I am multiplying 1 to this whole term. This is x square plus 3x plus 2 plus. Now I will write here 1 by 3 and d is a derivative operating on this total function. And what is derivative of this function? 2x plus 3 plus, I will write for this term. This is first of all I will write here 1 by 9 because 3 square is 9, and d square, this is d square operating on this, means we have to take double derivative of this, and double derivative is 2. Here is a d cube, third derivative becomes 0 and higher derivative becomes 0, which is equal to minus 1 divided by 3d into, this is x square plus 3x plus 2 plus 2x divided by 3 plus 1, I am multiplying by this 1 by 3 plus 2 by 9. This is nothing but minus 1 by 3 into, now 1 by d, 1 by b means we have to take integration of every term. X cube divided by 3 plus 3x square divided by 2 plus 2x plus 2x square divided by 3 plus x plus 2x divided by 9. I am taking integration. 1 by d means integration, d means derivative, and from this we are getting minus 1 by 3 x cube divided by 3 plus, this is 3x square divided by 2 and here is 2x square divided by 3. You can 9 and this is 4, 13 by 6 x square plus, now here this is 2x plus 1 3x, and here 3 plus 2 by 9, 3 plus 2 by 9 we have to take, we are getting here 29 by 9 into x, and this total is our pi. Now here important thing is that when we are solving this type of problem, if constant term is there, then we can take constant term. Moreover, remember in this way we have to take lowest degree term as a common, and then we can solve this problem. Okay, now we will discuss Next method, and in this method we are taking x equal to e raised to power x into v. Our right hand side is e raised to power x into v, and this v is function of x. This v is function of x. Now what is pi? How we will find pi under this method? Again, our formula is f of 1 upon f of d into e raised to power x into v. For this method, we can write here, first of all, I will take e raised to power x outside. If you are taking e raised to power x outside, then we have to make a change in d as d plus a. I am changing this d as d plus a into v. In this way, if our function is e raised to power x into v, we can find pi. And our formula becomes e raised to power x into 1 upon f of d plus a into v. I will take one example. Again, this is somewhat simple. If my differential equation is d square plus 2d plus 1 into y is equal to e raised to 2x into sine of 2x. Now this is under this method, e raised to x into v. V is function of x. Means I will write here pi as 1 upon d square plus 2d plus 1 into e raised to power 2x into sine of 2x. Our formula tells that here, if our function is e raised to power x into v, then we can take e raised to power x outside, and we have to make change in this d as d plus a. Here also I will write in this way, e raised to power 2x, and our value of a is 2 here. Therefore I will write this as 1 upon, I am changing d as d plus 2 whole square plus 2 into, I am changing this d as d plus 2 plus 1 into sine of 2x. This is nothing but e raised to power 2x. I will simplify this. This is a d square. Here is 4d and here is 2d plus 6d. Here is 4 plus 1 plus 9 into sine of 2x. This is nothing but e raised to power 2x into, now again I will apply here shortcut method. If our function is sine, if our function is sine, then we are replacing this d square by minus a square. Here is a square, I will write directly 4 plus 6 into d plus 9. Means here, if sine square or hyperbolic function, trigonometric or sine hyperbolic function is there, sine or cos function, then we can replace d square by only minus a square into sine of 2x. This is equal to e raised to power 2x into 1 divided by 6d plus 5 into sine of 2x. Now here square term is not there, therefore I will multiply and divide this by e raised to power 2x into 6d minus 5, and I am dividing here 6d minus 5, therefore I will write directly d square minus 25 into sine of 2x, which is equal to e raised to power 2x into 6d minus 5, and we have to replace d square. This we are replacing d square by minus a square, means 36 into minus 4 minus 25 into sine of 2x. This is equal to e raised to power 2x. I will write here this term as 6d minus 5 whole divided by, we are getting this as we are getting here minus 169 into sine of 2x. I will take this term outside, e raised to power 2x, we write minus here 169 into 6d minus 5 into sine of 2x. Now I am operating this term on sine 2x. Minus e raised to power 2x divided by 169, 6 into Derivative of sin 2x is 2 into cos 2x minus 5 into sin of 2x, and hence we are getting total answer as e raised to 2x divided by 169 into 12 into cos of 2x minus 10 into 5 into sin of 2x, and in this way we can find our PI. This is our PI. Using this method, only hint is that if our right hand side function means this x function containing e raised to power, this is product of e raised to power x into function of v, then we can function of x v, then we can write here, we can take e raised to power x outside, and then we can write here this is 1 divided by f of d plus a. And last shortcut method is there, and this last shortcut method is in this way. If our x is x into v, again v is function of x, v is function of x, then here pi is 1 upon f of d for x into v is equal to, we can write here formula 1 minus f dash of d divided by f of d into 1 divided by f of d into v. This is our formula when our pi is for this function. Or sometimes this formula we can write in this way also. This is x into 1 upon f of d into v minus f dash of d divided by f of d whole square into v. Only I am multiplying this whole term to this x and this term. Sometimes we can write this formula in this way. Most of the time we are using this formula here. Again I will take example on this. If my function is d2y by dx2 plus 4y is equal to x into sin x. Now here this is x into sin x. I will find pi for this. Here I will write this function as d square plus 4y is equal to x into sin x. Therefore my f of d is d square plus 4 into x into sin x. Now here is x into sin x. This is function of just like x into v. If x into v is there, then x minus f dash of d divided by f of d into 1 upon f of d into sin x. Here this is equal to, I will write x minus its derivative f dash of d, means we have to find derivative of this. This is 2d divided by d square plus 4 f of d into 1 upon d square plus 4 into v. V is our sin x. Now again I will use here shortcut method. This is a d square plus 4 into 1 divided by, here a is 1, therefore this is minus 1 plus 4 into sin of x. Now this total is a constant is 1 by 3. I will take outside. This is 1 by 3 into x minus 2d divided by d square plus 4 into sin x. Now I will multiply here. This is 1 by 3 into x into sin x minus 2d divided by d square plus 4 into sin x. Means this operator, this total operator operating on this function. This is equal to 1 divided by 3 into x into sin x minus 2d. Again we are knowing the sine function is there, then we are changing in d square. This is minus 1 plus 4 into sin x. This is equal to 1 by 3 into x into sin x minus 2 divided by 3 into d of sin x. This is 1 by 3. I am taking minus 2 divided by 3 here. This is 1 by 3 into x into sin x minus 2 divided by 3, and derivative of this term is cos x. And this is your pi if our function is x into sin x. and all these are the shortcut methods to find out pi. Again I will revise here. Shortcut method to find out pi. First shortcut method, 1 upon f of d into e raised to power x is equal to 1 upon f of a into e raised to power x. Moreover, f of a is not equal to 0. If case fails, then we can write x into 1 upon f dash of a e raised to x. Means this is equal to 0. Second, 1 upon f of d square sine of x or cos of x. In this way, our formula is here f of minus a square into sine of x or cos of x. Again, if case fails, here f of minus a square is not equal to 0. This is 0 means case fails. Then we can write x into its derivative. Same formula works for hyperbolic function. F of d square into sin hx or cos hx, 1 upon f of a square into sin hx. Moreover, f of a square is not equal to 0. Again we are knowing that method. If this is 0 means for failure case. Then 1 upon f of d x raised to power m. This is the polynomial. If polynomial is there, then we are taking only its inverse and x raised to power m. Using this we can find. The next 1 upon f of d into e raised to power x into v. Now v is function of x. Here we are taking e raised to power x as common. If we are taking e raised to power x as common, then we have to make a change in d as d plus a into this v. And last method, 1 upon f of d into x into v. Here you can write x minus f dash of d divided by f of d into 1 upon f of d into this v. By using this shortcut method, we can find pi for our given linear differential equation. Okay, in coming lecture we will discuss next method to find out pi. Okay, thank you.